Okay, welcome to the video covering question number 6 on inverse functions. This is from our proving inverse functions set, part A. For question number 6, it says, given the following set of points for two functions, determine if the functions are inverses. So here I have f of x contains the points negative 3, 19, 2, negative 6, 7, negative 31, 12, negative 56. Now, generally, what I could do is just check to see if the second function here, g of x, has those points in reverse order. So instead of negative 3, 19, I'd be looking for 19, negative 3. And I do not have that in this set of points here. I also don't have the inverse of 2, negative 6 down in this area. Same with the last one and the other one. So what I need to do is come up with functions that represent, or come up with the equation that represents each function, and then I can compare the two functions using function composition to see if they are inverses. So for f of x, when I had the points, we're going to assume right now these are linear functions. That's what we're working with. So what I'm going to do is I'm going to pick two of these points and come up with the slope and the y-intercept, and then I'll have my function for that. So for the slope for f of x, remember slope is change in y over change in x. So all I need to do is find two y values. I'm going to pick the easier ones for me. We're going to go 19 and negative 6. It does not matter. As long as you follow the same order, I'm going to go 19 minus negative 6 or 19 plus 6. And then it's negative 3 minus 2. So we end up with 25 over negative 5. And this is going to give me a slope of negative 5. Okay. Next, I need the y-intercept. So the y-intercept can be found by taking y minus the slope times x. And all you got to do is pick two values. So I'm gonna choose a point and plug those into y and x, and since we already have the slope. So in this case here, let me rewrite that. My y, I'm going to use the negative 6, so it's going to be negative 6 minus my slope of negative 5, so plus 5, times my x of 2. So we have negative 6 plus 10, that's going to be minus 4. So my b is negative 4. This is going to give me a function for f of x as negative 5x minus 4. Now I'm going to do the same thing for g of x. Again, same rules. It's looking for the slope. So change in y over change in x. That I'm going to choose, let's go with this guy right here, because I like the negative 1 and 1, and I might as well just use the one next to it. So we're going to go backwards this time. 6 minus 1 over negative 26 minus negative 1. So in other words, negative 26 plus 1. This gives me 5 over negative 25. So this simplifies down to negative 1/5. Next, so one thing to note is these are reciprocals of each other, and that is one of the key indicators that this is most likely or possibly inverse functions. I do need to determine a little bit later if it's going to return, the composition returns x. So solving for b, I get y minus mx. So my y, I'm going to use the 1 and negative 1 here. So y minus m, which is now minus a negative, so plus 1/5 of negative 1. Okay, so this is 1 minus 1/5. And you're taking 1/5 away from a whole, so that is just 4/5. So b is 4/5, and that means that g of x is equal to negative 1/5 x plus 4/5. And now all we got to do, if they are inverse functions, we just choose one to go. We can take the composition of f of g of x. As long as it returns x, then we do have inverse functions. So f of g of x equals, my f is -5, and then I have x, which is now g of x. -4. I then take this, I'm going to expand this just a little bit here. We're going to go -5 of -1/5 x plus 4/5 -4. Okay, we're going to distribute. We have -5 times -1/5, that leaves us just x. -5 times 4/5, that is going to give us -4. I mistakenly have something somewhere here. Let's see if I can discover what I did. Negative, so it's positive x, -4, -4. Was I supposed to have -4 over here? I was not supposed to have -4 with my f of x. So here I had +10 -6. That should have been +4 in this case. So I'll go back and fix this. Okay. I did that because I started recognizing that this wasn't going to be an inverse, but it was supposed to be. So in this case here, we get additive inverse with the -4 +4, leaving us with just x. So the composition of f of g of x returns x, therefore they are inverse functions. There you go.